Syntell breakfast seminar. We're about to witness a book release. The topic of today is software engineering in a systems context, and our partner Bud here will present the book. He was one of the editors of the book, and he will present some highlights from the book. And we'll also end up this morning with a lottery. I think you have 2 books that you will, some lucky guys here will have with you when you go. Otherwise you can buy them online, of course. I'll just try to steal a few minutes talking with who we are at Syntell. We're a 20-year-old company working within systems lifecycle management, we call it. It's really about, we support our clients with the acquisition or the development of complex systems. And we do that with a lifecycle perspective, making sure that the effect you want is there, but also it's there over time, basically. We have our presence, our headquarters here in Stockholm, but we have quite an international profile. We get asked by our clients internationally to support them within our areas, and when we do that we see a lot of good examples, a lot of best practice, and we bring that home to Sweden and try to bring that with us back to our clients, of course. And we work within 4 areas. It's a more management type of services where we work with change management and try to build the capability with our clients. We work with project and product management, but basically we have 2 strong legs. One within the systems engineering area, which Tom here started 15-20 years ago at Syntell. And the other one is integrated logistics support, and this together, of course, connects into this systems lifecycle management notion. And we have a range of services within our portfolio, spanning from strategy services and business development services all the way down to project support, more resource type of support. But everything is done with a purpose to build the capability of the client, of course. And one important tool then becomes training, education, which is one of our areas when we deliver trainings and courses. And this, of course, this event is one of those things. So why do we think what Bud is supposed to talk to? Why do we think that is important? Yeah, you see this every day. You hear the buzzwords. The products start to connect with each other. By doing that, they can create a lot of data, and we can communicate that data back to us. We can improve our capability within analytics of that data. You saw another seminar here this morning. It's about big data and analytics. And also, when we do that, the systems start to connect and become smarter and smarter and start to live their own lives. I don't want to tell you about this because you probably have expertise in this as well. But this is what we see with our clients as well. But the thing is that the typical products that we work with every day, they also are affected by this, and they will also become cyberphysical systems in the end. And our clients are going down this path as well. And this, of course, makes software engineering in the systems context extremely important for us. But the notion of cyberphysical systems, when they start to live by their own, also put demands on us to actually follow the development of the system. The notion of a design and the operation continuum, that is really not the case anymore. You will continuously develop your system over the lifetime. And then software, of course, becomes an important tool to understand and affect that trend within the system. But we also see that software becomes, it has been important for 10-15 years anyhow, but now with this trend that we see today, it will become increasingly important. And the software part of the systems, they will more and more be able to realize system functions on the top system level. And that makes it even more important, of course. But what we see daily in our projects and in our clients is this cultural difference. You have different approaches to the problem. No one is right, and that's why I took forks and a more Asian way of eating. No one is correct and no one is wrong, but you need to understand the differences, and you need to be able to manage the different parts of the system in the way that they need to be managed. And because otherwise it will go wrong, and we see that also within our clients. And a few years ago, Bud and I and some other consultants from Syntell were in like a haverikommission within a client we had, where they spent 10 years and billions of dollars on a system where they tried to introduce a software part of it, and the lack of understanding of the requirements on that eventually was one of the key things that made this project fail. And we see this every day, and that's why we think what Bud is supposed to talk about today is really important. So hopefully the book will give some more insight in what we see every day. Okay? You probably all know Bud, but I know that Bud will also present himself, so good luck. We have about 45 minutes to talk about the book, and then we have questions afterwards. Okay?
Very good. Well, thank you, Daniel, and thanks to Syntell for organizing this breakfast seminar. Well, today we're here to introduce a new book, which is just coming on the market, Software Engineering System Context. And as Daniel says, I will make a lottery at the last and 2 people will get copies of the book today. But the book is available at a very, very reasonable price over Amazon, the UK. I would recommend you use Amazon.uk. Okay, but anyhow, well, this is the title. And some of you know me. I don't think everybody knows me, but I've been in the computing and systems arena since 1958. So fastly approaching 60 years of professional experience. And so during this time I've done several interesting things in hardware and software and systems of various varieties. And so I have been lucky to be honored for these activities, being a fellow of 3 important relevant organizations, and also receiving a IEEE Computer Society Charles Babbage Computer Pioneer Award, of which I'm one of about 115 people in the world that have received that award for an invention I did in 1964. Okay, well, I don't think we can debate, as Daniel mentioned, the fact that software has become a central figure that is very, very important, and we have many problems in handling it. And one of the things that was pointed out already 10 years ago was that software has become the critical infrastructure within the critical infrastructure. And this was by Alan Salisbury, a colleague in the UK and the United States, who I've known since the 70s, actually. He's a former commanding general of the US Army Information Systems Engineering Command, and also was co-founder and editor of the Journal of Systems and Software, strangely enough. So this was very important to point out, is that we're living in a dangerous world, and it's getting more dangerous all the time. So the era of cyber-physical systems and the Internet of Things will certainly be a game changer for software and systems engineers, demanding the unification of the 2 professions. It's not a question if, it's a question that we must do it. Okay? And hopefully this book will be a start to get some initiative going and moving people in the right direction in order to achieve that type of unification. Okay, what makes software a problem? This quote by Frederick Brooks, who was my boss at IBM in the 1960s, was very relevant. about the software business. The uniqueness of software business stems from the peculiar nature of software systems. Intangible, free from reproduction costs, continually changeable, more complex than perhaps any other human construct. And this is important, requiring team-oriented, intellectual intensive endeavors, and tolerate no mismatch among the interfaces of system components. So this is, I think, a very insightful thing. This is an often cited book called The Mythical Man Month, which explains his experience with complexity of putting forth the set of software for the System 360 during the 1960s, which I was involved in. Well, okay, so software engineering actually, after got its real start in about 1968. There was a meeting in Garmisch as software suites continued to grow and be more and more complex. It was decided that we needed to really work towards structuring. So NATO sponsored a meeting in Garmisch, and there the idea of software engineering arose. And since then, I would say there's hundreds of different approaches to dealing with software. And there's a lot of trial and error. People don't really know how to deal with software, and based around the context they're working in, the situation may change for various types of applications, etc. So this has really been a serious problem. And there's been, while there's been a lot of things, there's not been any way to look at unifying these perspectives. So a few years ago, Richard Soldi, who is the Chief Executive Officer of the Office Management Group in Boston, Bertrand Meyer, who's a professor at Zurich, and also of the Eiffel programming language, and Ivar Jakobsen, who many of you know. How many people know of or know Ivar? Perhaps some people. Okay. Okay. Ivar is a rather special guy. I've known him since the 70s. I was on his doctoral committee at KTH, and I helped him write his first book. So we've had a large number of experiences together. But he was one of the driving forces behind the development of the object approach that was used in the AXE switching systems at Ericsson. And has been a very well-known author. He's also involved in the development of the UML description language and root, rational unified process, and other things. So they decided it was time to do something about this problem. Okay, so, and they made this statement: software engineering suffers from the prevalence of fads more typical of the fashion industry than an engineering discipline. Okay, and the lack of a sound, widely accepted theoretical basis, the huge number of methods and method variances with little differences, little understood, and artificially magnified. So, and lack of a credible experimental evaluation and validation, and a split between industry practice and academic research. And I think we've got to address those problems. So this was the, and if you go in, you will find at CMAT.org a lot of information about the CMAT effort. It's gotten, and it's a growing effort. There are a few thousand members in the CTAP, and you can join this if you like yourselves into this effort. Okay, one of the concrete activities that has evolved from the CMAT effort is what we could call refounding software engineering. And this is CMAT supports the process to include a kernel of widely agreed elements, extensible for specific uses, address both technology and people issues. It's not always just a question of technology. We have a lot of problems with people working in teams. Are supported by industry, academia, researchers, and users. Support extension in the face of changing requirements and technology. So this resulted in the development of an Essence kernel, which was developed by a group of about 20 people, all software engineering experts around the world working together. And it has resulted in an OMG standard. So the Essence kernel, you can go into OMG's website and you can download the Essence kernel standard, free of charge. Okay, so I can recommend that. There are also some books. One book has come out from Addison Wesley about the Essence kernel. And in, of course, this book, there's an introduction to the Essence in chapter 2, which was quite useful, and also some history about Essence and its development. So you'll find a fair amount in this book as well. So, as I mentioned, it resulted in the object management standard on the Essence kernel. But let me give you a feel for Essence. What is this really about? How do we achieve something that is widely agreed? And well, we need to get back to looking at what's fundamental. For all approaches, not just for one. What are they trying to achieve? Well, this group managed, I think, to do an excellent job of coming to a perspective on that. And so this was very, very important, and as Essence evolved, and Eva contacted me quite early in the CMAT effort, and I've been a supporter, what they call signatory for several years of this Essence approach. But we decided that really we need to move Essence also into systems engineering, not just software engineering. Okay, and so we decided that we would work together on a book and edit this, and we would bring Essence as one important part of the book. But the book is not just about Essence. There are many people that have contributed that are known software and systems engineers around the world who have contributed chapters to the book with their perspectives on the issue. So there's a lot of meat in the book. Each chapter can be read individually, but there's a lot of cross-references. So people have read the other people's work and related them in a neat way, as a matter of fact. This has taken me over 2 years to produce this book. It's not been an easy job. Okay, but it's been, I think, a fruitful start to an important endeavor. So here's the cast of people that are involved. Luckily, we have one in the room. Ilya, could you raise your hand? It's Ilya Meter back there, who's contributed a chapter to the book and also has read and commented on many of the chapter's work. Some of these people you might know. Barry Beam is quite well known for the spiral model. And Barry is my tennis partner when we meet. We often play a lot of tennis together. And other people like Tom Gill. Rich Hilliard was the editor for the IEEE 1471 standard on software architecture description, and also for the 42010 on systems architecture description. Eva, of course, and myself. Anatoly Levenchak from Russia, and Svante Lehman, who participated in the effort, and Paul McMahon, he was one of the 2 leaders of the Essence kernel effort. He organized it. Marcel is from Brazil, with a very nice chapter on acquisition. Okay, and it was important. Barry Meeber from South Africa, Han Wei from Singapore, Don O'Neill, who's had a long, long career in IBM as both a systems and software engineer, and is very vocal in writing about these issues in various journals, etc., and has contributed, in fact, several chapters in the book. Okay, a very important point. Jung Soon Park from Korea, who's done a very, very nice chapter on information systems and how Essence can affect that area. Sarah Sheard, who's a very well-known both software and systems engineer, working at Carnegie Mellon's Software Engineering Institute in Pittsburgh. Ian Somerville, coming from St. Andrews in Scotland, and he has produced probably the most sold book on software engineering, selling over 1 million copies. This up to issue 10 now, and he's written a nice, an interesting chapter on social technical systems. And Ian Spence, who's also a colleague of Evers, working on the work with Essence, etc. as well. So this is the cast of characters. So you'll find a lot of wisdom, I think, in this book, from different perspectives. So I would say that it's a must-read for all software and systems engineers. They need to get this in their minds and start to work with it. Okay, within the book, we explore software system relationships, and there are many perspectives. Sometimes people don't agree with each other. Okay, and that comes forward in some places as well. But it's important that we allow people to state their perspectives. So you'll find some driving concepts and principles, some guidance on selecting development approaches, issues of complexity, stakeholder concerns and requirements, the vital role of architecture, agility and governance, quite a bit about relationship and discussing agility, resilience, trust, and risk, which are very vital issues for systems in general and certainly for software systems. Acquisition and supply chains, which are very, very difficult to handle in this environment. When you subcontract out parts of your work, you have enormous problems in this regard, and how to control that type of situation. This issue called technical debt that has arisen up, that you try to postpone certain things or ignore certain aspects during the development, and this piles up as a problem. That's been somewhat accepted in certain quarters, but several of our authors don't like that idea. So you'll find some interesting perspectives on technical debt in the book. Social technical aspects, as I mentioned, Ian Somerville wrote a nice case about a Scottish system for digital learning education. Then about standards, Francois Pallier, who's the head of the ISO IEC effort on systems and software standards, has written a very nice chapter on system standards, and also has related some aspects of why this is important in the standards area and the system perspective in moving towards smart cities. And there's a new smart city standard starting to evolve that he's quite involved with as well. So it's very interesting. And he points that out in his chapter as well. Fundamental aspects of improving communication and understanding. And then, most importantly, a call for action to strive towards unifying software and systems engineering. We need a systems engineering kernel that is, hopefully, maybe we can unify it completely, but it must be very related so that we can improve communication between software and systems engineers. Okay? Because that's where we have enormous problems. Okay, so I'm going to give you a very brief view of the Essence kernel, which I would call a framework for thinking and acting. So what has evolved is that they've identified certain aspects which they call alphas. And there's a mnemonic for that, which I won't bother to go try to cite. But alphas is these types of things. And you they've divided the situation up into 3 areas of concern. The customer area of concern, the solution area of concern, and the endeavor area of concern. So what they're basically saying is that we always have some type of stakeholders for a system, and that they provide an opportunity. The opportunity may be to fix a problem. Okay, so don't view that only as an opportunity. Okay. And the stakeholders demands requirements. The opportunity focuses on requirements. And then we build a software system that fulfills the requirements and is used and consumed by stakeholders, etc. But I won't go through all these connections, but the important part, I think, and really I think one of the major contributions of Essence is in this area. People, I was architect of the ISO IEC 15288 standard on software system lifecycle processes. And that's a very important standard from a systems engineering perspective, and it's described and referenced quite a bit in the book, as a matter of fact, and tried to relate to how we could use the ideas in that within this context as well. But that standard really doesn't, that standard really doesn't address these issues. Because you want to be able to talk about teams and how you build teams, how you put them together to deal with things. You want to then talk about the work that is actually being performed, and you want to talk about the way of working. Okay, so you need to be dealing with this area in order to improve our ability to deal with complex systems in software and systems in general. So these we call things to work with. You're working with these things. Okay? And then it talks about things to do. And these are things that were quite logical and quite straightforward. In this area of concern, you explore possibilities, you involve the stakeholders, you ensure stakeholder satisfaction, and you use the system. In the solution area, you understand the requirements to shape the system, implement the system, test the system, deploy the system, and operate the system. And in the endeavor, you prepare to do the work, you coordinate the activity, support the team, track progress, and stop the work. Now, these are completely generic. And regardless of what method you find, you're probably going to find these elements in that method somewhere. Okay? So this gives you a generic way of maybe looking at methods and practices from a completely different perspective. So this is the important part, is to be able to do this. And then the last part is we talked about the competencies that you need. You certainly need to have stakeholder representation in the effort. In the solution, you do analysis, development, and testing. And in the endeavor, you're going to need both leadership and management of the endeavor. So this is Essence in a nutshell. A quick question.
Very quick question. Having not been very much involved in systems engineering,
Okay.
but very much in how we run corporates, this seems to be fairly, as you said, it's generic, but also, say, from a management perspective, if it's not systems or software, it's actually how you run an operation, which could be anyone.
I completely agree.
Can we agree?
It's very generic about doing anything.
Yes.
Okay. And so that's maybe pointing us in the direction that might be useful to work in towards working towards this unification. Good point. Thank you. So these are the competencies needed. Okay, so that's the essence. And behind each of these alphas that we talked about at the beginning, there's a set of states that you proceed through. And the people that are working on this, 20 or so people working on this essence effort, have agreed upon the language for that and what the states are, and they're written in rather quite understandable language. Okay, and from behind these states, there are also some types of checklists which you can use in order to improve your deeper understanding of achieving those particular states within those alphas. Okay, so this is described quite well in chapter 2 of the book by Eber himself and some other colleagues. So Eber and I have contributed some chapters as well as taking the other people's perspectives. Okay, defining practices and work products. So for each of these alphas that we can talk about, they really organize and relate to work products. They could be documentation, they could be the actual software system, or some other system, or user information, or other types of things. So the alpha has an alpha state. The work products is evidences the fact that you have moved into the alpha state. The alpha state is progressed by activities. These activity spaces target the alpha state. And then we organize the activities. So these activity spaces that we talked about, things you do, are filled with concrete activities, okay, that you actually do in order to achieve that. And the activities requires competencies, and the competence profiles the team role that is qualified to perform this thing. Now, this particular picture appears in chapter 15, a chapter by Lawson Park. Which is quite known, quite well-known person in Korea. And also he's the head of the CMAT effort, as a matter of fact. Okay, now Lawson also did a nice experiment, and we'll show you the fact that this is practice and method independent. And in order to prove that, we can look at the Scrum approach, the practice of Scrum, described in essence. And it looks like this. Okay, so we have this Scrum practice here, and you're dealing with requirements and the software system. You have a product backlog, it's a work product, and a sprint backlog. These are work items, right? Okay. Definition of done and product increment. In the work being done, you have a release plan, which is about what the sprint goal, a sprint plan, and total work remaining. And then the team deals with the Scrum team and actually build it up. The way of working involves also an improvement plan item. And here you're working on understanding, whoops, something ahead of me. You have to be careful when you push this button. Let's see. Understand the requirements. You get a product backlog refinement. Ensure stakeholder satisfaction. You do that with producing a sprint review. And then we have coordinating activities, supporting the team and tracking progress, where we get these ideas of sprint planning, daily scrums, and sprint retrospective. So this is described in terms of essence. And there's also a description of the other currently very, very popular approach called SAFE, Scaled Agile Framework, is also describable in this. Well, okay, that's a little bit about essence, and that I think can form the basis that we can move forward. At the same time, we've had a serious problem that most software engineers know probably, and maybe view life as programming and coding, and don't really understand the fact that dealing with complex suites of software involves a hell of a lot more than programming and coding. Okay, so they do not have a system perspective. And so one of the important things was to give them an important systems perspective. So I've written a chapter in the book called Attaining a System Perspective, but I can highly recommend that you buy volume 1 of our system series, which I wrote a couple of years ago, called A Journey Through the Systems Landscape. Ula probably knows this book. But this, I think, give you a much deeper perspective on systems. Not just about software, but systems in general. Okay. Okay, but I'm only going to give some highlights. There's a lot more details, but I'm going to show you some things that are in particular chapters, just to give you a flavor for what's there. So I've always talked about learning to think and act in terms of systems, and I think this is a fundamental capability that people need to develop. And unfortunately, people are very compartmentalized and don't think about a system perspective. And that's why I wrote that book earlier on. But within the book, I developed a new paradigm, which I call the system coupling diagram. And this is, again, very generic, as Matt say, because I can apply it to anything. We talk about a situation system. We talk about a respondent system that is done to deal with that particular situation, hopefully transform that situation into a new situation. And then we talk about system assets, which are instantiated in the respondent system in order to deal with that. And obviously, we get into a lot of systems management questions related to managing these assets and seeing these assets are in good shape. Doesn't help if I have a jet fighter plane that's not working. Okay? That instance, I need to be able to bring it in. Or I don't have a finance system in order, or I don't have other issues that are important from that perspective. So, we give names to these systems. So, for example, in the situation system, we could talk about a natural system. We could talk about the situation is an earthquake. And we need a response, right? We could talk about the situation is that it's a man-made system of hardware or software or both, and we need a response in order to deal with that. Okay? We can talk about a thematic system, which might be a game built up like a business game or a war game, and we simulate a response. It's the same model. Okay, so, and here are some examples of system assets. It could be facilities, instruments, theory, knowledge, standards, methods, practice, frameworks, tools, etc. Or the essence kernel is really an asset. Right? I can build a response to a situation using the essence kernel and building my response based around that. So these are some examples. And that's described in chapter 3 of the book. Okay, and then there's a lot more in that. And as I recommend, that chapter is kind of a summary of what you will find in more detail in this book. Okay, some aspects of it. Okay, Don O'Neill did a very interesting chapter about infrastructure resilience. It's related to the comment of Alan Salisbury that we have the critical infrastructure within the critical infrastructure. We're dealing with large power systems, telecom systems, banking systems, medical systems, etc. that are all out there that are very vulnerable. And we see hacking attempts and other types of things, and we get failures. And we can get a situation where we can get cascading failures. This starts here. We see that certainly in power systems. That goes down, and that goes down, and that goes down, and that goes down. How do you deal with such situations? What is the response? What is the response to this situation? So Don gives some very, very interesting wisdom about how we may try to address this problem in the future. with some new perspectives, and he uses both the system coupling diagram and he uses the essence kernel in this chapter to describe approach to move forward in this area. So he has applied the system coupling diagram, and here the situation is that we have a large number of critical infrastructure systems, right? And if we get failures, certainly if the electrical system goes out, it's going to affect everybody, right? Okay, the telecom system goes out, no way to do any banking transactions. And we have all the medical efforts. The transportation, we can't move people or goods around. That was a serious problem as well. Okay, so these are examples of some of our critical. And Don calls for the development and the education of a group of people that we don't have today, called intelligent middlemen. And he brings up the fact that there's a respondent system here that is going to respond to this situation that is based around interoperability, operation sensing and monitoring, coordinated recovery time objectives, and he calls this digital situation awareness. And we have a distributed supervisory goal for intelligent middlemen, shut down alternate sites, information and data recovery, and cascade triggers identification. Nobody's really doing this, probably at the level that must be done. We are very vulnerable. And so these are some of the system assets. Okay, he describes some essential aspects of addressing this problem in terms of both essence and the system coupling diagram and some other aspects like clean method and process, etc. Very important chapter, and as I said, Don's contributed several chapters. We then have a chapter on complexity for systems and software that talks about both objective complexity aspects, which are concrete things, and more subjective complexity aspects, which are more subjective, of course. And this is a very, very good chapter. It's probably the best chapter I've ever read about complexity. Done by Sarah Shearer, who's quite well known in the systems and software engineering circles. We then have Barry Bean has contributed his incremental spiral commitment model, where it deals about moving through various stages, which he calls exploration, evaluation, development, foundations, operation, development. So you move through, and as you move out in these spirals, you get involved with risk decisions. Okay? Do we know enough about this in order to proceed? Have we achieved certain results, etc.? So this is a very well-known model, and in fact there's a whole book by Barry that describes things. And he brings up several case studies where the ideas behind certain key principles, which he talks about here, have been obeyed or not obeyed. Okay, so it gives you some wisdom of some concrete examples that are taken up there. And as I said, that's done by Larry Dean. Then we have an architecture description, which is done by Rich Hilliard, as I mentioned, Hilliard, who is the editor of both IEEE 1471 and this ISO standard 42010, which describes the importance of getting architectural descriptions that represent the concerns of various stakeholders in developing a system of interest. And it develops the idea of architectural viewpoints and architectural views and architectural models. So this is represented in a UML-like notation. And so that's an architecture description meta model. And then he talks about cross-cut familiar entities. And he relates this to essence. Okay? And talking about Because really what we're trying to do with Essence, even though we have these three areas of concern, we maybe have many, many other concerns that will affect the practices that we'll use in actually accomplishing our tasks. Okay, like reliability and safety and other types of, these are real concerns. So it might very, very well affect our way of working. So he does a nice job of relating this notion and this thinking to the Essence environment. That's Rich Elliott. Now there were some guiding principles for developing Essence. Principle 1, common ground that accepted by a broad community without poor compromises. They were very hard about that. Natural naming developed the names of alpha states and arriving words and checklists were constantly attuned to choosing words that fit naturally with software practitioners. The checklists have an intentional ambiguity, intentional because the role is to stimulate conversations and not be prescriptive. Keeping them all small at all costs, we do not dictate the number of states and the number of checklists, but we're always conscious of keeping it small enough so practitioners could learn them all in a relatively short period of time and start using it, gaining value without extensive training. And I think they've accomplished that. Okay. Now, one additional requirement that we're thinking about for if we're doing a systems engineer is Principle 5, reuse as much as possible. Since Essence is an existing standard, the development team must motivate what has to be changed relative to the standard. In the search for the Essence kernel for systems engineering, work should start from the existing standard. Okay, and this is in a chapter 16 by myself and Eder and Paul McMahon, who, as I said, was one of the leaders of the Essence effort. So we give a call for action. And exactly as Matt said, organizing this effort is like organizing any other project. So we can use Essence and take our own medicine. There's a clear opportunity. The stakeholders are all system and software and their surrounding community of interest. All managers, all leaders, etc. should be involved in that. Requirements have started to be identified in this book, but need to be further developed. The system of interest is the Essence kernel for systems engineering. The team should be seated with people that participate in developing the current Essence, experts and users of 15288 and 42010, as well as the most popular standard in the United States for several years was the capability maturity model. The goals of the work are stated here. The ways of working must be established by the team. Okay, then I will skip over this. This was done by Ian Somerville. I'll talk about social and technical systems, but he comes for a digital learning environment in Scotland. And he comes up with a proposed architecture, understandability based upon use, lessons learned, and important issues for Essence. Because when you're dealing with such a wide thing, it's very difficult to establish requirements. It's to deal with people from 3 years up to 80 years of age. And how do you get requirements for such a system? It's a very interesting and thought-provoking chapter. And then Ilya has contributed a nice chapter about applying a system perspective, where he talks about 3 interacting systems: the software system we're developing, the context system, and the project system, which is really the team. Okay? And so these are very neatly described. And then Ilya provides also case studies which eliminate both successes and failures in respect to both traditional system development and agile system development in that chapter. Very nice chapter. Well done, Ilya. Okay, finally, I'm just going to go through quickly the book contents so we get I'm going to give a few highlights. Richard Soley and Bertrand Meyer, who have been the initiators of CMAT, and also Richard is the CEO for Object Management, who have written very nice forewords to the book. Then the book is built into 3 parts. Part 1 is called Framing and Situation. And that's Eva and myself did the first chapter. This gives you a description of CMAT in the Essence kernel. Then I have this attaining a system perspective. Then Don O'Neill has this about applying the ideas in critical infrastructure resilience, complexity. Barry Bean's chapter. Then Don provides a chapter on trustworthy risk and technical debt. Francois Collier, as I mentioned, did a very nice chapter on standardization. And Rich Hillier about architecting, an architectural description. Effective governance enable success by Barry Nieberg. In part 2, we focus more specifically on the Essence kernel and aspects of that. Okay. A framework for thinking and acting done by Paul, who was the leader of that effort. Constructive approach to the analysis as alpha state sequencing done by Don. And a way forward, a strategy for harmonizing Agile and CCMI, which are in conflict in many issues, but he has some ideas about how one might proceed in that. And trying to convince people in the United States government, particularly the military, to adopt those ideas and not look this as 2 different areas, but to try to unify that. He's written quite a bit about some of the magazines in the military side in the United States. Yunsun Park, as I mentioned, business systems. Then this chapter is really setting the frame for moving forward, okay, towards the systems engineering essence. In addition to that, there's some perspectives provided by Don O'Neill and Anatoly Levenchek. Then part 3 addresses some important aspects like social technical systems, and Ilya's chapter, and then a chapter by Tom Guild and Lindsay Brody about capturing requirements, endeavor subcontracting, and the case of supply chain risk management. This chapter 20 I mentioned here was interesting, and he describes a number of practices in essence that can be used in the area of subcontracting. Very interesting. Principle-based fixed-price contracting is Rutgers game change. He gives this is a case study, as a matter of fact, itself. Okay, acknowledgements. The editors, of course, thank all the authors, especially Mats Persson, who I would hope who didn't here today. Mats has been my right-hand man in commenting, editing, and integrating the book. He's been he actually helped me with this first book as well, some years back. He's had worked for Schwarzer School. Steve Bailey, a friend and colleague who's reviewed some earlier things. Richard Soley and Bertrand Meyer for the thoughtful forwards. Alan Salisbury, Martin Rees, Danish Verma, so many people in this room know Danish. Cecilia Aston, Asmus Pandekal, and Jakob Oxelson have all provided endorsements for the book. Okay. So, that's where you can get it. Purchased on UK Amazon, about the price of a main course at a better restaurant. But the whole idea with the system series that you've gotten a little notice about here is to provide books at reasonable fees. We don't want to rob students. And we want to spread information. And making books that cost $100 or $150 is certainly counterproductive in that situation. So this is why we've, and I've established this with the college publications in King's College in London. And so I would suspect if you want to, there's information on these books, both these things, but use the UK one for beginning. There are some problems. This has not really been completely updated. So if you do it, buy it in pounds. Okay, and you can order it starting next week. Okay. If you go into Amazon.uk. Okay, that gives, I think, a fair introduction, and I think hopefully we can really move forward. It's important for Syntell, it's important for Sweden, it's important for both all the companies working with software and systems, and for the research and academic institutions as well. So we need a coordinated effort to move forward. And I'm looking for some talented young people who will take the ball and do this and make it happen. Okay, so there's a real opportunity. And it's a real opportunity for us to make something, a real contribution from Sweden to working towards this type of unification, which is important for the whole world, basically. So, thank you.